can all hear me okay. I have very fond memories of the University of Saskatchewan. I got my first initiation into very cold weather in Saskatoon. So it always brings me a lot of fond memories. Um, Today I'm going to talk about, just let me make sure you can see my slides. Okay, all right. Okay, so today I'm going to talk about an issue that is of very significant relevance to the meat industry, specifically the pork industry. This is work that I have done with Dr. Ellen Goddard and other collaborators over time. And we are specifically looking at the application of technology to improve disease resistance in the pork industry. Um, as a motivation for the topic, the issue about disease is really, really important. And I think even the times in which we are, it's appropriate to talk about disease and with the COVID situation, but specifically for the pork industry, we are talking about a number of major diseases that have significant economic implications. PCVD, PRRS, PED, that has a lot of economic implications because of their impact on the hog head. Now, in recent times, we've also heard about the African swine fever and the amount of devastation that is caused to the industry, particularly to the Chinese industry. So disease resilience is a very important concern for the hog industry. The research I'm presenting today is sort of a narrative over a decade. And so I'll try to do as much as I can in view of the time that we have. But as part of the social aspect of the Genome Canada project, we have been looking at three important issues. I've been looking at adoption from the producer side, public acceptance, and market implications. And for today's talk, I'm going to specifically focus on the issue of public acceptance of different innovations within the hog supply chain. All right. In terms of public acceptance, I want us to see these two perspectives. Okay, the issue about using technology to improve the trade itself. So acceptance of the trade enhancement aspect of it, as opposed to acceptance of the technology. And these two are distinctive, as I'll share with you as part of this talk, that the acceptance of the improvement of a trade doesn't necessarily imply an acceptance of the technology. So we'll take it step by step. First of all, we are going to look at the trade enhancement. What is public acceptance? I will first present evidence from 2012. We'll follow a very linear timeline. So in 2012, we started to look at issues around public acceptance of PRRS and PCVAD, which are important hog diseases. We asked our sample the extent to which they will buy pork chops that are bred for disease resilience. So in the first question, the emphasis was on the trait itself. And then in the second question, we tried to look at the tool. Okay, so we try to look at the method, genomic selection versus the use of vaccination. And this is how the survey was set up. This is what the respondents saw. This one is for the method question, where we talked about genomics as opposed to vaccination. And as you notice, interestingly, we found that in general, there seemed to be a rather strong and positive willingness to pay or valuation for improvement in the trade itself. As you notice from the line, this distribution, the trade itself had a rather positive, significant willingness to pay across our sample. The method also tended to was positive, but you noted that the distribution was a bit far to the left, which means that the dichotomy between the valuation of the improvement in the trade and of the method. And I will spend a bit more time to talk about the technology as we proceed. The next work that we did was in 2016, where we looked, again, going back to the questions that we have addressed before, to look at preferences for disease resilience. We use two types of framing. We look at it from the perspective of a consumer, and we also look at it from a perspective of a citizen. In the citizen framing, we try to capture some of the public good dimensions of improvement in the trade. When we did that, we noticed that majority of the willingness to pay was between 0 to 15, 15 to 5, sorry, dollars per kilogram. And we also noticed that in terms of the distribution, the citizen decision generally tended to have a higher valuation as compared to the consumer decision. And sort of the literature is well developed on why that happens. People really tend to think about sort of the public good dimensions, the free rider effects, when they are making the same decision within a citizen context. And we thought that this was even more prominent when we are talking about an issue of a disease in the head. So we keep going along our timeline. In 2019, we did a small survey of 300 respondents and sort of using the similar framework to see what the choice would be. We asked them whether they would buy pork from pigs that have been bred for higher disease resilience. Yes, no, sometimes, and no, I would never buy. What we ended up doing in this particular survey was also to ask them how certain they were of their choices, the choices that they made, right? So these are some of the summary of the results. Most respondents, as we have noticed from the previous years I've shared with you, have said yes, they would buy. Relatively few said no, they will not buy. And an intermediate number was in between those extremes. Then we also asked them the level of certainty about the choices they make. Most of them said they were very certain. We noticed quite a high proportion were uncertain. So what we did was to juxtapose their responses to the level of uncertainty. And you notice from this last chart that most of the people who said no were quite uncertain about the choices, which in essence, I think highlights the fact that there is room for some fluidity in terms of their perceptions about the product. Now, the next bit of the story is specifically focused on the technology. What are public perceptions about the different technological approaches that we can use to achieve the trait enhancement outcome? And as you may be aware of, there are a number of different approaches that can be used: genetic modification, gene editing, genomic information, use of probiotics, vaccination, and so on and so forth. So what we did was that in 2017, we asked respondents in terms of the level of perceived risk that they thought was associated with the use of the different technology. This chart shows the result of the least risk, or what they perceive to have the least risk. And it's interesting that relatively they had a more favorable perception towards the use of genomics and less so towards the use of vaccination. And it is the public getting being more adverse towards vaccination? Are we picking up on that? I think that's a very interesting story to pursue. But we notice that in terms of likely risk, they tend to be more favorable towards genomics, and perhaps in a comparable way towards probiotics as well. All right. So let's look at more of the technology questions in the more recent survey. So here we asked them the application of different technologies to achieve different things in two industries. So for pork, our focus, as it were, was on the disease resilience attribute. And for dairy, we looked at the dehorning and how technology can be used to achieve that end, just for us to see whether the impact sort of differ across species. And as you can tell, in general, we gave them the option of most preferred, least preferred. And in general, most people within the pork analysis were more thought that conventional methods were most favorable, 46% against 51%, more towards genomics in the dairy. And we noticed that of the methods that were presented to them, there was sort of a strong aversion towards the use of gene editing. And I think that's very interesting, because you are seeing some form of comparability between the application of different technologies to achieve different ends. The last bit of results, in the interest of time, I will show, this is from our most recent survey, where we looked at the determinants of the preferences for purchasing pork as compared to preferences for different technologies. So first of all, we will focus on this table, which looks at the purchase decision for disease-resilient pigs, okay? And as you can see from some of the results that have been highlighted, people with higher environmental attitudes tended to be more likely to purchase that. Trust in industry tended to be less likely. Trust in research, and then trust in the ability of government to be fair was also negative. And so these are some of the patterns that we are seeing in terms of the effects. Interestingly, when we move to the preferences for the different methodologies, you notice some differences. Okay, so for example, let's look at the role of government in managing biotech in terms
Albert, you're at 10 minutes now.
Time is up.
You got 1 more minute.
Okay, so let me finish this very quickly. So you notice that, for example, trust in research, although was positive in this case, when you look at gene editing, it was negative, which was a result that we think require more explanation. All right, so I will end it here. I want to acknowledge the contribution of some of the people we have worked with on this project, Violet Moringaya, Anahida, and also thank Genome Canada and Genome Alberta for their financial support. Thank you for your attention.
Great, thank you, Albert. We've got time for a quick technical question while we switch from Albert's presentation over to David Castle's presentation. Does anybody have a quick question that they would like to pose to Albert that can be answered in 30 seconds or less? Seeing none, then we'll move forward. David, over to you, please.
Okay, let's see if I can get this to. Hang on a second. It's not letting me share the screen. Hang on, it's just decided to
maybe while David reconnects, Anna, we'll move on to your presentation.
Sounds good. I'll do that. Give me 1 second to get mine sorted out.
Sure.
There we go. Let's see. And I'm hoping that you can see the screen okay. Okay. Right. There we go. Yeah. Well, my name is Ana Maria Bogdan, and I'm with the Canadian Hub for Applied and Social Research at University of Saskatchewan. And I'm here today to talk about an exciting project that it's very early on in its stages. We were hoping to have something a little bit more than this to present today, but I'll be speaking predominantly about our thoughts regarding this approach and this research, which we think it's quite relevant and of importance. So I'll be talking about behavioral research data in agricultural research. And with that in mind, 1 second, I'm having, oh, there we go. Yeah, so I'll be focusing on farmers' adoption behavioral data. And the reason for that is that, this comes part of some of the study that I've done before, where I looked at farmers' adoption behavior related to improved water management practices and technologies in Eastern Canada. And by going through that literature, I realized that, there are a lot of inconsistencies and a lot of means for us to come in and improve the way in which we handle research data management on that topic. So first of all, if you think about agricultural environmental policies and their success in tackling environmental issues and in setting forward a sustainable agricultural production development, it is important to have farmers' endorsement when it comes to the adoption of these proposed practices and technologies that the government and other entities come forward with in terms of solutions, of providing those solutions and advancing sustainable development goals. And to that effect, agricultural environmental policy focuses in part quite a bit on influencing farmers' behavior, and within that they try to understand the behavior in order to be able to predict and inform agricultural policies. Human behavior related to the process of adoption of new agricultural practices and technology has been tremendously researched and documented in the scientific literature, with some of the most recent accounts coming from just this year by Pennell and Zilberman. And we know that within the decision-making process, there are many factors that come at play. And we also know that from this body of work that there is no unique configuration of factors that explains farmers' decision to adopt or not a particular innovation. So with that in mind, we observe that a lot of studies come up with mentions of, depending on different contexts and circumstances, we'll see different configurations of factors that come at play and become important in that adoption decision-making process. Recently, Montes de Oca in 2020, in one of their studies, they mentioned that, within this field of research on adoption of innovations in agriculture, there seems to be, a lot of lack of convergence between studies on agricultural adoption, finding different explanatory variables highlighted in different cases. So they also say, okay, we need a common approach in order to establish guidelines and best practices for data collection, analysis related to this area of research, mentioning that this can further help design better policy responses. And that's where our interest lies as well with this research. We also believe that by while in the past, we have focused tremendously on the heterogeneity existent in socioeconomic and biophysical factors that are true and are essential in agricultural production, and it poses challenges in developing overarching solutions that lead to speedier adoption of improved agricultural practice and technologies. But even though there is a need to account for these heterogeneous factors, we think that there can be some common grounds in identifying how that information can be used in a more comprehensive way. So within the scientific community, researching adoption behavior and diffusion of agricultural innovations focuses less on developing these sorts of overarching frameworks and data management systems that allow for a consistent and rigorous treatment of this data. That can enhance the usefulness of this research data to policymakers, extension officers, businesses, and researchers as well. And this can be done by ensuring we're collecting data and we're storing data, we're handling it in a way that it's easy to find, easy to access. It can be interoperable, and it can be reused, not only by researchers, but by other practitioners as well. And within the Canadian agricultural sector, we see a multitude of stakeholders that are part of this innovation landscape within agriculture. They're involved in creation of knowledge, funding, performance, implementation, and so on. The public sector within Canada, continues to be one of the largest funder of agricultural research and development, whether it's performed in public or private settings. Federal and provincial governments are the key funders of research, infrastructure, commercialization, development, and extension activities. And Canada does play a prominent role in the production of agricultural research, as I think in 2017, it was ranked the 8th worldwide in the production of academic papers related to agriculture, with more than 90,000 records published between 1997 and 2014. So we do produce a lot of knowledge related to this, of course. In terms of funders, when we have a quick look in Web of Science, we know that some of the main funders of research related to agriculture spanning between the last 2 decades, we see some of the 3 agencies, Canadian 3 agencies, with the top funders being Natural Science and Engineering Research Council of Canada, Agricultural, Agri-Food Canada, and Social Sciences and Humanities Research Councils. So Canada has made some progress in developing an overarching framework for research data, committing to enhance research data management and accessibility. And within that, as Canada's main funders of research, the Canadian Institutes of Health Research, the Natural Science and Engineering Research Council, together with Social Sciences and Humanities Research Council, have mentioned, and I quote, are committed to a shared approach for improving access to publicly funded research in keeping with internationally recognized best practices, standards, and policies for funding and conducting research. So a fairly positive note in the sense that there is a broader overarching movement within Canada and elsewhere to move towards developing these rigorous systems and following fair principles in sharing and handling research data. So with this research, what we are proposing to do is to look at, we want to accomplish 3 main things. The first one is to understand the type of data that it's currently being collected and to evaluate the extent to which this research data related to farmers' adoption of agricultural innovations is accessible, available, and reusable. In other words, it is in line with some of the FAIR principles. But we also want to understand what are the current practices of data collection and usage in agricultural products, of agricultural producers' behavioral data within the Canadian government, and to assess the extent to which scientific research data is useful and included in the process of developing agricultural policies. And lastly, and this is a broader goal, is to explore the need for developing a framework to conceptualize the normalization of research data in the area of human behavior and adoption of agricultural innovations. And in order to achieve each and one of these objectives, well, in the first case, as I said, our intent is to look at the literature over the last 20 years in order to understand, when it comes to behavioral data, what kind of data is it that we are currently collecting? What kind of metadata do we currently have, and how useful is that metadata in making the current research data that we collect usable reusable. We want to see the quality of we want to be able to assess the quality of the data that is currently being collected, whether it's shared or accessible. If it's shared, we want to know what are the sharing methods that are currently in use. Is it easy to access? Can it be reasonably reused? What are some of the estimated costs collected related to collecting this kind of data, and how can it be processed? How was it processed, analyzed? Can it be representative of a group, subgroup, and is it generalizable? So all these questions, they're picking apart the information or the data that we collect in this area, it's with the higher aim of really understanding whether we have what we need in order to make better use of this kind of data that we're collecting, and if we can learn from one study to another, and if we can figure out a way in which we can systematically record this information and make better use and build on previously done research.
1 minute.
And
Anna.
for the
Anna,
second
1
major
minute.
objective, excuse me?
1 minute.
Thank you. I'm almost done. For the second objective, we would want to understand current practices of data collection and usage within ag policy in the Canadian setting. So for that, we were contemplating using social network analysis to map stakeholders within the government that are involved in developing policies, and to trace through the social network analysis, the information sharing related to behavioral research data in order to understand how it enters policy. And for that, to that extent, we would like to also conduct some in-depth interviews. And for our last objective, which is indeed the overarching one of developing the framework, or to explore the need to which that could be of use. We were thinking about reviewing and cataloging the characteristics of already existing platforms of behavioral data sharing, but also having a mixed panel of experts discussing the usefulness of developing such a framework and repositories for behavioral research data related to adoption of innovations in agriculture. Thank you. I have some references here.
Thank you, Anna. David, we'll
You're welcome.
jump back to you to hope that your technical issues are fixed now. Oh, there we go. Perfect.
And there, how does that look?
Yeah, that's good.
That's good. Okay, good. Sorry about that, everyone. I had updated some software and had a security block that I had to remove for sharing my screen. So there you go. Thanks, Anna, for going ahead. My discussion here is actually about some governance and policy challenges that are arising through what's called Agricultural 4.0, and I'll explain what that is in a minute. And this is some work that I've done collaboratively with Stuart, but also with Peter Phillips, both of whom, of course, people will know are at the University of Saskatchewan, through which I have a kind of an adjunct professorship as well. So I'm based at UVic, but I've had continuity with USask as well, so part of that family as well. So this is some work that we've been doing on trying to understand what the implications are for what's being called the fourth industrial revolution, which has been described here, I think, quite nicely by the World Economic Forum as the unprecedented advances in technology that are transforming the way that individuals and groups across society will live, work, and interact. And in particular, you can think about it as the enablement of different ways of doing things that arise from the production of information and communications technologies, but also the massification of those, which allows for the movement of incredible amounts of data, computational efficiency, and analytical tools. So all those sorts of things are described in the book by Klaus Schwab, The Fourth Industrial Revolution. Now, so people have been noticing that indeed aspects of the fourth industrial revolution has shown up in the context of agriculture, agricultural production systems, but also distribution and retail systems as well. So pretty much all of the global agricultural value chains are in one way or another affected now by digital technologies. And so Project Breakthrough, for example, I described this as the integration of all of these technologies into essentially one kind of overarching system through which food production could be improved. But of course, there are other aspects to it apart from just agricultural productivity gains. There are some issues that I'll be describing here in a minute. So let me just give you three quick examples of different types of enabling technologies from the fourth industrial revolution that affect agriculture. So one would be the Internet of Things and machine learning that can accelerate or open up new opportunities to breed plants, animals, microbes that will offer opportunities for yield gain and for quality improvement. So different kinds of technologies, for example, technologies that allow you to actually quickly sift through using machine learning to see whether or not new plant varieties are succeeding or not succeeding in different environments, done basically digitally as opposed to manually. Here's another example. Many of you will be aware of this sort of thing already being quite widespread in industrialized countries where precision farming couples GPS and different types of sensors or drones, different kinds of algorithms to essentially increase outputs and reduce inputs into agricultural systems. Sometimes it can be down to less than a square meter of resolution in terms of the application of herbicides, for example, on a plot, or doing very sensitive drone-enabled assessments of soil moisture, for example. And then this is more on the supply chains and where Agricultural 4.0 will hit consumers, is using internet-enabled methods to amass big data that help you to actually understand how markets move, how niche markets develop, and to think about different ways in which producers and consumers could communicate directly, but also alongside the very massified kinds of approaches to supply chains, the sort of thing that Amazon and Whole Foods would be pursuing. So there are a number of different issues here. I think you can probably guess that obviously there's, wherever there's data flowing, there are questions about who can access and own that data. It's certainly the case that if you look at the work of companies like IBM, they are amassing agricultural and weather data and then trying to sell those products and services back to farmers, for example. And then there are other issues, of course, that are arising around the fact that we're increasingly relying on digital sequence information as opposed to direct contact with biological resources. So this is also raising some interesting issues under Nagoya with respect to the movement of that information around the globe. There are implications for infrastructure in the sense that we are now having to modernize things such as plant health networks to have essentially a digital backbone to them as opposed to a grow, wait, and see approach to understanding whether or not our plants imported or new breeds are working well in our environments. There's, of course, international data sharing protocols, which are becoming increasingly important. And we do have to then think about the ways in which we're actually going to have physically coupled and virtually enabled supply chains around the world. The third issue bucket, I would say, is the question about food security and sovereignty, which is understanding how these information communication technology enabled changes to the way that we actually grow, move, and consume agri-food will have major issues with respect to state-based versus international regulatory regimes. We'll be thinking more deeply about where data comes from in order to be able to make assessments of regulatory approvals for novel organisms. And then the question again about supply chain control, which becomes quite independent of source and destination countries and can actually be either truly internationalized or part of a third jurisdiction. So these are some interesting new aspects that'll impinge on food security and food sovereignty issues. So essentially, I think what we have to be working towards is understanding what the governance challenge is here and how to respond to it. You could state, as I have here, that the presumptive goal is presumably to optimize an increasingly digitalized global innovation system, especially since these global value chains are going to be anchored in this emerging digital architecture. But I think that you can say something easy like that about optimization, but I think in practice this is going to be very difficult to do because we're talking about increasing role of exponential organizations which have very low capital footprints, casualized labor. Most of their assets are in information. And they can scale up and scale down and move rather quickly. So they're a difficult governance target for thinking about how to regulate these kinds of organizations. Anybody who's ever followed, for example, taxation issues around major social media platforms, for example, will certainly appreciate this kind of an issue. But the other part of it too, of course, is that these kinds of organizations all have massive transformational purpose in the sense that they're not like a privately owned business that's just around the corner that has more or less stayed the same way for generations. The point of these things, much like in the case of social media, is to massively transform the way people do things. And so the consequence of this is that we tend to think very much about agricultural production systems and where agri-foods are consumed as falling under normal state-centric attempts to use domestic regulations to exert that control. But I don't think that that's going to be true for very much longer. Now, some people have suggested, World Economic Forum has suggested this, for example, that we have to track this with some kind of agile governance, taking into consideration that government roles will be reduced and that there will be some kind of a multi-stakeholder approach to this. They've offered all sorts of different kinds of mechanisms. Personally, I find these mechanisms sound very much like the kind of language that people used to use about the the total freedom to share information and the ubiquitous seamless contact with individuals that people used to describe the internet 20 years ago, and it's turned out to be something quite different. But the idea, for example, that you would have crowdsourced policy making in a jurisdiction where otherwise you entrust that to regulatory authorities strikes me as being somewhat implausible. I think a more sort of plausible way of looking at this is what General Electric has been doing in terms of thinking about scenarios for the fourth industrial revolution and how it'll impact them. And if you look at the bottom right, there could be just a total hands-off, just say, governments say, no, we're actually only really interested in a certain set of restricted powers, and we'll just devolve all of the rest of this to other lower level authorities, or just leave it up to communities to sort this out in the extreme case. Other options, another scenario would be that countries just say, look, we're just open for business and we'll have very light regulatory touch over all of these kinds of technologies and the companies that enable them. You could, of course, have state control, which might be tempting in the situation where you have a government that's more inclined to take over successful private sector actors and then operate them in the state's interest primarily. But we'll leave that one to one side. I'm actually more interested in just this question about what we can actually do in the short and longer term in terms of thinking about managing the market itself. And so I want to just finish here by proposing that there are actually two models that we know of right now. One of them is essentially a private model where you have competitive private regulators. So these are companies acting in a sense as self-regulators, but they do it in a compact form, and then are overseen by public regulators. That, in a sense, is what the European Union data protection laws is all about. Or you can actually have a kind of public super regulator, which is, again, overseen and contributed to by state public regulators. But again, it remains not in the private sector's hands, but in the public sector. And that would be very much like the European Union digital single market. So where I want to close with this is just to observe that at this point in time, I think we're probably looking at, in reality, the de facto situation is that we have a combination of the two. Some self-regulation, but also some public regulation of agricultural 4.0. And I think that what we need to be doing is thinking about a scenario down the road, 5-10 years, in which we actually see the major organizations such as the World Bank and the Food and Agriculture Organization of the UN taking a more active role in developing public super regulatory capacity in order to be able to work with and monitor some of the activities in the private sector, especially if we have competitive private regulators that are starting now to actually work actively more in their own interests than in the public interest. And so I'll close with that. So thank you very much.
Great. Thank you very much, David. Jacques, over to you for your presentation, please.
Thanks, Stuart. Am I hearable?
You bet. Yep, looks good.
Okay, thanks. Well, thanks for this opportunity to share a few thoughts and prejudices. Let me introduce my topic by saying that I think when I first submitted this idea to the conference, as it was going to be in February this year, I thought this was sort of new and exciting somewhat. And as the years moved on, I think it's much less so. And even today, I was on 2 Zoom sessions that more or less talked about the same topic. One was Michael Kramer gave a public lecture at FAO this morning on digital extension stuff in Africa, especially. And another at the World Food Prize, Maximo Torero from FAO also talked about the same issue. So I'm not alone out there in these particular prejudices that I'm about to share with you. How do I advance my... Sorry, can you help me hit the right button?
If you click on the screen with your slides, it should advance just like a regular PowerPoint.
Thanks, Travis. And thanks very much for reissuing my invitation for this session, which I'd managed to lose. So briefly, some historical reflections. I started to think a lot about the issues of problems in effective extension back at the turn of the century, and I published a couple of pieces basically outlining all the difficulties that are inherent in old style extension as it was practiced and supported by various agencies such as the World Bank, where I was partly guilty with some of the operations that were put in place at great public cost and rather limited public benefit. Over the years, I've struggled with how to do it better. And at the beginning of this year, I decided to update my thoughts about all this in the light of the sort of emerging digital reality in which we now find ourselves, so that the final item on the screen is the longer version of the paper I'm presenting today, which is available on the Rutgers website. And I'll also later point to a smaller, shorter, easier version of the same thing. So what's the way forward in the new digital era? In short, what I've found very satisfying to reflect upon is that many of the problems that I pointed to in my earlier works on this topic are very readily overcome with effective implementation of digital tools. And so I think the future of agricultural extension, it's always been an important, potential important topic, but I think it's going to be much more important in a digitally empowered world. And sorry, the political calls keep coming in. I think it's absolutely critical to search for greater cost effectiveness in the way extension works and delivering new messages, whether it's new science-based information or market-based or whatever, that the mechanisms for getting new information to users who can, maybe they're small farmers, maybe big farmers, but all players in the agricultural sector need much better access to information, and extension services, both public and private, provide lots of good ways of now doing that. So what's really required, and this is the really short version of the paper, but this is my three big conclusions about what we need to do. Critical is the status of the telecommunications infrastructure, particularly in the more remote parts of the developing world where it's still quite patchy. And so massive investment will be required to really give access to all the potential users of extension-based information. It seems like the idea of universal service and access funds has been around a long time, but it's seldom really been used, especially in recent times, as far as I can see. So those parts of, especially Sub-Saharan Africa, where communications systems are still so weak in many remote areas, we need a lot of fresh thinking and probably fresh donors, which may be not just private sector, but international NGO type support as well, to start to fill the gaps in this infrastructure. Another general conclusion I come to in the paper that I'm really speaking to rather than delivering is the importance of developing relevant skills to use digital tools. And in government extension services, there's still a long way to go to get everyone up to speed. It's not just a matter of getting them some sort of smartphone or semi-smartphone, but they really have to develop skills around how to use that and how to integrate effectively with their potential clients. I guess the good news on this front is that the young people of developing societies seem to be very able and willing to get on top of these skills quickly, and they can help some of the oldies make the necessary steps. A third area of concern I have about what should be done is dealing with I guess it's really in general, the quality of information. And here I've called it the authenticity of information that goes into agricultural advisory services. There's already a significant problem in the increasing role of private extension being not necessarily as objective and independent as one would like to see, to give farmers and other members of the value chains really good, reliable information. So I think that we need a lot more work on that in general. So I'm trying to be very quick and sharp in my presentation. I've waxed eloquent on this topic in an AgriLinks session a few weeks back at USAID, where they also broached the broad topic. And as I mentioned before, a short version of what I would have liked to have said if I had lots of time to play with today is available in written out form in a little policy brief on the Rutgers website also. So with these few thoughts, let me close and look forward to later discussion. Thank you.
Well, thank you very much, Chuck. That's very interesting. And for those of you following closely on the program at home, you'll notice that we've got a slight change in speakers. Graham Job is not going to be presenting the next paper, but his co-author, Jack Fotheringham, is going to give the next presentation. So, Jack, the floor is yours for the screen, I guess it should be.
Well, thank you, Stuart. That's excellent. I'm just going to see. Perfect. I think we've got it figured out there, if everyone can see.
Yeah, looks good.
Awesome. Sounds good. Perfect. So hello, everyone. My name's Jack Fotheringham. I am a master's student at the University of Saskatchewan in Political Studies. My co-author, Graham Job, graduated from the Master's of Public Policy program last year. And Dr. Peter Phillips, who's familiar to some of you, to be sure, is supported our work for this. So thank you to him as well. So yeah, we'll get started. So our project and our paper was on a citizen science-driven approach to food security in Sub-Saharan Africa, which neatly ties in, probably not by coincidence, with a lot of the presentations offered here today. So we'll start off with what is citizen science is probably a good place to start. So citizen science is defined, I guess, most recently in the Oxford Dictionary as a scientific work or scientific work generally undertaken by members of the general public and often in collaboration with or under the direction of professional scientists and scientific institutions. So a few years ago, Graham and I did a project on citizen science, and we sought to come up with a framework to analyze how, I guess, what it is that makes citizen science projects work in the way that they do, some of the things that they have to offer relative to other forms of science. And so in terms of common areas of application, we noticed a few for sure. There were, many in the ecological space, as well as in astronomy and measuring and analyzing data in a primarily biological context. So We noticed that right off the bat, and certainly historically, that had characterized most citizen science projects. Citizen science is also touted often as a means to produce positive attitudinal changes towards scientific research and learning among participants in general and as members of the general public. So that's another positive function of it. But in addition to those factors, there are some specific advantages of citizen science that offers, I guess, unique advantages as a research tool. And so some of these include the increased number and geographic distribution of participants. So rather than paying a limited number of graduate students, for instance, to go out and collect field data, instead, citizen science projects are poised to motivate individual citizens to go out there and do it themselves. Frequently, these people are hobbyists. So for instance, amateur astronomers, or people that care about, for instance, the water quality in their area. And so they go out and take water samples, or bird watchers is another classic example. And there's also scalability, as one can see from this increased number and geographic distribution of participants. Because there are more participants, and because, especially with ICT and sort of Web 2.0 interconnectivity, we're able to see participants collecting, submitting, and analyzing data from all over the world. So that has created a major benefit. There's also a scalability as well, or pardon me, a cost effectiveness, partly because we don't have to pay people because they're doing it for their own reasons, but also just the specifically in the analysis as well. It's a major benefit to have people using their own computers, for instance, and doing their own analysis, and then sort of through a distributed network being able to analyze data. The public engagement I've already spoken about as well. And so in terms of food security specifically, which is our topic of choice, and specifically food security in Sub-Saharan Africa, which we'll examine in a moment, we see a number of applications for citizen science projects, or in a more expanded form, perhaps, crowdsourced projects as well. And so 3 of them that come to mind immediately are seed development and innovation, environmental and crop data collection and analysis, and human mobility and data analysis. So for seed development and innovation, this would include things like community seed banks, participatory variety selection projects, and participatory plant breeding projects. For the environmental and crop data collection and analysis, this would include land use and land cover data analysis projects, waterfall and rainfall observations on soil conditions and pests, as well as crop disease observations. The human mobility analysis could entail basically a means to predict human responses to famine and ecological disasters, and we'll see some of this in some of the case studies that we look at coming up here. So up next, we have our categories of citizen science, which is our conceptual framework. This is something that we had established in our previous work. And so we see we've got 4 main categories of citizen science projects. One of them we don't have any case study examples for because, well, we have some hypotheses as to why that is. But in terms of active data collection, this is some of those ecological projects I mentioned. People go out in the field and they actually collect samples and then report the data. That would be an example of it. In terms of passive data collection, this one is not quite as certainly an example of citizen science, in fact, mostly because it's not as participatory. So for instance, and we see this with a paper written by Zufiria later on, the data is collected passively through people's phone, like mobile location data. So that one is still crowdsourced, but is not really participatory in the sense that we normally think of it. And then also unskilled data analysis, where people without a requisite level of skill, they're not experts, they're able to analyze data, and then that data is aggregated for use and analysis later on. So now in terms of why food security and why Sub-Saharan Africa, why are we extending this framework of citizen science and the categories of projects to this setting? There's certainly a utilitarian case to be made where there are, of course, major problems with food insecurity in Sub-Saharan Africa. Unfortunately, poverty and malnutrition rates have been rising since 2015. So we think that perhaps a novel approach could be useful. These CS-driven approaches, partly because of their low cost, but also because of their low barriers to entry and their scalability, they might be particularly well suited to overcome common barriers to food security and agricultural development in Sub-Saharan Africa. And so, for instance, the lack of infrastructure, which previous presenters have already mentioned, even with subsidies and even with improved crop varieties, we don't always see these projects take off. And so looking at how we can improve outcomes for smallholder farmers with potentially indigenous seed varieties, for instance, for home consumption is a particularly interesting way to approach development, and CS-driven projects are perhaps a really good way to address those things. Thirdly, the capacities already exist to some degree in many countries in Sub-Saharan Africa. For instance, local ethno-agronomic knowledge, but also mobile phone networks, which are not fully extended or fully developed, but they are increasingly so every day. And with the use of ICT for citizen science style projects, we could see how these kinds of networks are poised to essentially allow CS to be used as an avenue to development. And there's also existing development networks, which could be leveraged. So first we'll go to our first case study of active data collection. So we've got the TRICOT projects. And so a TRICOT is a, So it is a participatory variety selection, but this is a new approach. And so it uses a specific statistical model to use ranking. And it's also a single blind trial. So farmers are given seed packets and they are not aware of which one is which. And then at the end of the crop cycle, they rank rank order the performance of each trial plant with respect to its vigor, its pest resistance and disease resistance, and its architecture as well. And also compare it to their own local varieties. And so this project that we've examined from Van Etten here has continued to develop and evaluate the methodology and the potential of this approach. And we see that participatory variety selection, even when the participants don't necessarily have a high level of skill or even literacy, can still provide useful data for non-improved crop varieties, as well as there's also the potential of this style of project to automate some of the tasks and to reduce costs as well. Secondly, we have a passive data collection example. So this is another one that wouldn't traditionally necessarily be considered as a citizen science project because of the lack of participation. But in Senegal, there was a telecommunications network that partnered, a private network that partnered with a number of international INGOs and released anonymized data for mobile phones. And this was used basically as part of an academic challenge to come up with a way to use the data for food security. And so Zufiria and their collaborators used this to create these distinct human mobility profiles and then modeled or used the profiles to model human responses to shocks such as ecological disasters, disease outbreaks, which we can see is particularly germane to the current context, and famine and drought, for instance. So this is another way to address food insecurity through a citizen science style project. Lastly, as we don't have the skilled data analysis, which I'll briefly address, it's just because there are not a lot of amateur agronomists sitting around apparently to analyze data. And so unskilled data analysis seems to be a more viable route. And so we use the GeoWiki project, which is done partly through USAID, and it also uses Google Earth's infrastructure. And basically the purpose of the GeoWiki project is to have online participants analyze land satellite imagery. And the particular project that we focused on was a project in which the imagery came from Ethiopia. And they found that through a ground truthing experiment, after doing this over the course of about 1 year, that the land cover products that were created through this project were more accurate than anything that existed at the time within Ethiopia or in any international aid organization. And so this demonstrates the potential for the CS approach to improve land cover data throughout the SSA. So we see that there are more pardon me, just one moment there. Excellent. Okay, so some of the things that make the citizen science approach potentially a better avenue is that it generally operates outside of profit motive incentives. And so in particular, we see that this can apply to the participatory variety selection is a good example. of something that there is no real necessarily profit motive to help smallholder subsistence farmers to develop non-improved varieties of seeds, some that aren't even commodified or commercialized. But this sort of approach operates outside of that structure. It can also provide a lot more information for government policymakers as well as non-government policymakers. There's also another dimension to the benefits of the CS-based approach in terms of developing food security and agricultural development in Sub-Saharan Africa, which is that participatory aspect that I discussed earlier with citizen science. And in particular, I think seeing smallholder farmers, maybe who even lack literacy, being able to participate in this kind of research and development and innovation, I think is a good thing for many reasons in addition to its efficiency. So in terms of the pathway to policy impact, and I'm sorry, I'm not sure exactly how I'm doing on time here.
1 minute left, Jack.
Perfect, thank you, Stuart. So we argue that the CS-based approach requires an iterative and gradually more coordinated efforts. Newer iterations of existing projects can tweak design, implementation, and objectives to better align with all of those, with those other adjacent projects, but all in the context of a coordinated and mutually beneficial large-scale food security effort. So for example, we've got, I'll just skip ahead just so that we're on track here. Right, so Enninkel is one of the authors, and we've got it cited here, but one of the authors that highlights that existing development networks can be useful. And so he highlights the idea of like stacking food security data collection with vaccination campaigns, for instance, or the distribution of tricot seed trial packets from existing aid distribution points, such as local churches, for instance. Leveraging existing capacities in this way will likely be crucial to the success of a broad-based CS approach to food security and development. And then lastly, I'll just focus on one aspect, which is moving from human-driven to automated processes. So one thing that is often brought up about citizen science projects is that a lack of sustained engagement, because volunteers get tired of what they're doing. They don't necessarily want to sit and analyze land cover usage, for instance, or soybean disease pictures all day, every day for about 5 years or something. And so this is a major issue, but now we're seeing with machine learning that these kinds of projects, in addition to providing the data analysis itself, can also provide machine learning data sets that people can use to develop essentially machine learning capable computing programs that can actually continue to analyze these. And so this is one thing that we posit as a solution to the problem of sustained engagement with citizen science projects, is actually moving towards these automated processes where this is a potential avenue to ensure the long-term value of specific projects and also to alleviate the problem of sustained participation, because the sustained participation itself is not necessarily the long-term goal of these kinds of projects, but rather a means to an end of more data analysis, essentially. So thank you very much, everybody. And I look forward to hearing your questions later on.
Great. Thank you very much, Jack. That sounds like interesting research you're doing there with Peter. And Intan, we'll bring it around to you now and get you to round out the presentations in this session.
Great. Thank you so much, Stuart. All right, let me just share my screen. Oh, all right. It says I cannot share screen until...
Jack, you need to unshare your screen.
Sorry, I'm just... Oh, perfect. Thank you.
There you go. Thank you.
Still getting used to it. Thanks.
Great, thanks. All right. Sharing my screen. Great, can you guys see it? Just.
Yep.
For some reason, I don't see it, which is not good.
Oh.
All right. So thank you so much for allowing me to present a paper that I basically co-authored with Greg Graff, who I believe is a frequent participant at the ICABR conference So I'm an economist, and I work at the World Intellectual Property Organization with the chief economist in the chief economist's office. And really, the way we look at things and what we're doing is we're looking at innovation-related topics, and particularly looking at it from an intellectual property perspective. And the reason why we actually start looking at the issue of plant biotechnology really comes down to one of our flagship publications, which is on the geography of innovation. So this is a flagship publication from WIPO. And what we try to do is we try to give an overview of the economic thinking on specific innovation-related themes. And the 2019 report really focused on looking at how the spread of innovation clusters worldwide may optimize knowledge exchange and innovation output. And in particular, what we're interested in is really trying to understand what is known as the Global Innovation Network, which is really a collaboration. Let's say it's a globally organized web of collaboration between organizations, be it firms or institutions, engage in knowledge production that result in innovation. So what we tried to do in this report specifically was we tried to map out where innovators are located and the researchers are located and who they're collaborating with. And here, what we do is we rely on footprints of innovators and researchers based on patent and scientific publications. I'll go into this a little bit more in the later slide. And this report really tries to look at, for plant biotechnology, where the innovators are, where the researchers are. And we use both patent documents and scientific publications because these two are, let's say, innovation outputs. And we know specific knowledge outputs may not be captured by patents. So that's where we also look at scientific publications. More specifically, what we do is we look at patent documents and we look at scientific publication. And for those of you who are not familiar, in patent documents, you have very interesting information. You have information on the date when the patent was filed. You have information on who the inventors are and also where they reside. And then with regards to scientific publications, we have information, of course, on the date of publication, as well as the authors and their affiliations. So we took these two together and we tried to map the innovation landscape. So for patents, we looked at patent documents that came from about 168 patent offices between 1970 to 2017, which basically translates to about nearly 9 million international patent families and 22 million inventors. And we have information of their location geocoded up to the rooftop level, basically to the building of the inventors. For the scientific publications, we look at the Web of Science, and we have information from 1998 to 2017, which roughly translates to about 24 million scientific articles, 62 million authors, and we have information for them geocoded at the postal level or the sub-city level. And this is particularly because with regards to university affiliations, you usually do not have the specific address, but you just know more or less where they are located. So here you see, which is a mapping of the Global Innovation Network. And what is interesting is that what we find is that the top 10 collaborative hotspots of the world account for about 26% of all international co-inventions. Now, what this basically means is that you have these top 10 cities, let's say, who are really collaborating with one another. They're your very frequent, highly productive cities. And these include Beijing, Bengaluru, Boston, San Jose, San Francisco, the Silicon Valley, basically, Shanghai, Tokyo, New York, Frankfurt, and Paris, to name a few. And the mapping of these locations have been very interesting and insightful for us because one, it tells us, where the innovation is happening, who's innovating with whom, and we can also see, to what extent this connection happens, like when it started happening. So for example, in the case of plant biotechnology, what we start realizing is that China, in the more recent years, has become a quite prominent innovator in the field. So I move on to the case study for the plant biotechnology. Now, for plant biotechnology, what's interesting for us in terms as an innovation economist is the nature of the plant biotechnology innovation. So you have a technology that is very much facilitated or promoted by scientific breakthroughs. So you have the CRISPR, the genome sequencing, and so on and so forth. And what has always been interesting is that there's an aspect that this particular technology in plant biotechnology needs to be adapted to the regional agroecological conditions. So which means that it can't just be, let's say, a plug and play. It needs to be adapted. So then there needs to be some sort of a translation of the innovation to the local regions. And also what's interesting for us is that when we were looking at studying the innovation ecosystem of plant biotechnology is that you have a strong role of universities and public research organizations in promoting the research in this field. And at the same time, you also have the private sector. So what's interesting in the private sector is that there's an increasing concentration in the seed, chemical, and fertilizers industries that when you look at the multinational corporations that are really doing the innovation and diffusing worldwide tend to come down to, let's say, the big top 5 chemical firms. And also what was interesting for us is the government regulation that comes in, not only with regards to what can be patented and what cannot, but also what can be commercialized in the planted and commercialized in the region with regards to, for example, food safety, security, biosafety, and also with regards to human consumption. So that has been very interesting in looking at the plant biotechnology market. So some of the questions that we have addressed in the paper include questions such as, where are the main location of innovation clusters? How do they connect? What's the role of the production side, academic centers, and markets in such network formation? Where did the production and innovation networks overlap, and where did they not? And we managed to answer some of the questions and not all of them. So here's the search strategy for plant biotechnology, meaning that how we got our data in mapping out the innovation in plant biotechnology. We use, for patent, we looked at the IPC CPC codes, which can be broken down to the technology improvements related to crop genetic improvements, soil fertility, pest controls in crops, and climate change. And in total, what we came up with is a total of about 500,000 patent documents. And they relate to about 193,000 first filings. Now, first filings are basically patent applications that were filed in a specific place or patent office for the first time. And the difference between the total and the first filings are really related to what we call the subsequent filings, meaning that, let's say, the same patent application that has been filed, let's say in the US for the first time, is then filed at the EPO. So this would be considered the EPO filing, which is the European Patent Office filing, would be considered the subsequent filing. And usually for us, the subsequent filing just shows the commercialization potential in different markets outside of the United States. For scientific publications, we looked at the top journals for plant biotechnology. And then we looked at top journals in general agriculture and science category, combined with specific keywords that relate to plant biotechnology. So for example, transgenic plants. And we came up with a total of about 93,000 scientific publications. Keep in mind, we do realize that we have a problem with regards to scientific publications because most of the publications were in English. So our next step is also trying to improve that by looking at different languages. Now, so we put together the information from patents and scientific publication, and we start looking at how the innovation landscape changed in plant biotechnology. So what you see here in this slide is basically the geographical distribution of global plants innovation from 1998 to 2002. And the blue parts are scientific publications and the green are patents. Now, what I'll ask you to look at, because I'm going to show you also an interval of 5 years, is how this landscape changes. So this will be the second one. third, and fourth. And what has been very interesting for us is the prominence of China, right? That has been quite interesting. Also, what has been interesting is that if you look, for example, in the beginning, let's say 1998 onwards, you see that most of the, let's say, innovation output in plant biotechnology tend to be from scientific publications. And then later on, you start seeing more patenting, which is quite interesting in of itself. So when we look at this, what we start realizing is that this is very interesting, because basically what you start to see is that there's a spread of innovation clusters around the globe. And here, what we've mapped are what we call the international plant biotech clusters versus the national plant biotech clusters. The difference between the two has to do with the fact of the density of innovation in those specific regions. So the green are the international plant biotech clusters, referred to innovation centers that have really high density of innovation in plant biotechnology. Whereas the mustard, say yellow, national plant biotechnology clusters refer to innovation, let's say regions in specific countries that show that there is some plant biotechnology innovation taking place, but that it may not be at the same level or density as the international. Why this difference is interesting is because, one, what we see is that, for one, that you have most of the innovation hotspots or innovation clusters for plant biotechnology in high-income countries. But you do see developing countries having some sort of innovation in this. Keep in mind, what we're focusing on is not where the innovation comes from, but rather who's innovating and where they're located. So we're looking at the inventors here. So while there's a spread of plant biotechnology across the world, what we do realize is that it is concentrated on some clusters. It's concentrated in high-income countries. Now you see, for example, with regards to patents versus scientific publications. So when you look at patents, you start seeing that, for example, clusters in the US tend to have high density, whereas in scientific publication, interestingly, places like Beijing have more prominence. What we also start realizing is that, for example, most of the inventors in plant biotechnology tend to reside in the United States. This has slightly changed from 1970 to from the period of 1970 to 1999 to 2000 and 2017. So it basically tells us that perhaps most of the researchers for this field are residing in the US. And that is something that we want to exploit more, because what we want to see is that, has there been change in the sense of from the US to specific developing countries? How has it progressed? How has it evolved? The other thing we noticed that's very interesting, what we tried to map is the innovation clusters for plant biotechnology, where the inventors and researchers reside. And then we superimpose land that is considered farmable land. So we were not able to find land maps that would show lands that were farmed, but we were able to show find a map that showed where farming could take place. And what we see, so this, for example, you see in the US, here in Europe, what's quite interesting is most of the innovation clusters tend to be in places where you don't necessarily have farming lands nearby. And you see this in the same way, and to a lesser extent, in Asia and as well in Latin America. The other interesting finding that we see is that there's an increasing rise in public-private collaboration. Now, keep in mind, when we look at the patent filings for plant biotechnology innovation, about 80% of that tend to be by the private sector. However, about 20% are collaborations, meaning that there's a co-application between either private companies, private-public entities, and even between public and public entities. Now, the increasing rise in public-private collaboration has been very interesting for us for two reasons. One is because of the nature of where we see institutions, public institutions, playing a big role in the dissemination of plant biotechnology innovation. But also we know that the private sector sometimes seem to have, let's say, a gateway to commercialization efforts. So the increasing share in the public-private collaboration seems to show that there is an increasing collaboration in the sense of bringing specific plant biotechnology innovation from, let's say, the research or the basic research to the market. So the few takeaways that I can share here, and you can actually see it more in the working paper that we have at the WIPO website, is that the distribution of plant biotechnology innovation across the globe is apparent. And we think that part of it is because of the multinationals' commercialization efforts. But the institutions such as the International Agricultural Research Centers and the National Agricultural Research Systems to promote and support robust, sustainable agricultural programs may also be behind this increase of the plant biotechnology innovation clusters. The other interesting thing, as I mentioned before, is the increasing rise in the public-private collaboration. And we would like to look into that a bit more. And the urban-rural divide is also an interesting thing for us to see, because so what we see is that innovation mainly takes place in the metropolitan areas, but that is something that we want to look at in further detail. And lastly, most of the plant biotechnology researchers tend to reside in the United States. So the next steps are we want to share the data. So we are sitting on this data and we want to share with everybody. So we're currently writing up the methodology, and if you want to have access to the data, please let us know and we'll be happy to share it with you. And then we have further research questions that we want to look into, which, for example, what role do institutions such as International Agricultural Research Centers and the National Agricultural Research Systems play in the creation and diffusion of innovation in this field? Also, what's the role of multinationals in the globalization of research development? And one way we're thinking of moving forward is actually to look at country studies. Now, WIPO has, and the Chief Economist's Office basically have a mandate for us to study and conduct research on innovation, IP, and socioeconomic development in developing countries. And for us, looking at plant biotechnology innovation might be very useful in terms of understanding what's happening in specific countries with regards to regulation, the innovation ecosystem, to actually look at the evolution of this technology in that specific country. And perhaps to even answer a bigger question, which is, has the changes in the global innovation network affected economic development of plant biotechnology clusters in the country? So we're looking forward to maybe collaborating with some of you on these questions, and just take note that we would like to, we have some funds to conduct these studies, and we're looking forward to that. So with that, I will finish my presentation. Stuart.
Great, thanks, Van-Tan. That was very interesting. Sounds like you and Greg are sitting on a gold mine.
And we'd like to share.
Well, at least it's better than panning in the Canadian Arctic in the wintertime. So that's a good idea. It might be easier to take you up to share this gold mine and do some mining of this in the warm comfort of our own home. So that's a wrap on the presentations, and I'd like to turn it over to anybody participating to ask questions of any of the panelists or to the panel. Culture?
Thank you for the question. I think we included the knowledge question in there, but I didn't report that. Normally in these preference studies, we would give them information about the technology. So we'll give them sort of that information before they make their choices. We'll tell them genomics is this and that, sort of give them a little bit of a background. So just to sort of even out, in essence, some of the information disparities that people may have. So we give them that in their choice preferences.
Great, thank you.
Can I ask a question?
Please go ahead, Carl.
Just on the swine, sorry, improvement. Doesn't almost all swine breeding now use genomic information? I mean, what was the difference between breeding without genomic information and breeding with genomic information? nowadays doesn't all of it use genomic information?
I'm not sure about the extent of utilization of genomic information, but we sort of gave them a variety of approaches that are being used, conventional genomics and then other newer approaches, just to ascertain what their preferences are. But as to the extent of utilization, I'm not privy to that information.
Mm.
Thank you.
Looks like there's a question from Gregory Graff.
Hi, can you hear me?
Yes, we can, Greg.
I want to thank everybody for some really interesting presentations. And for maybe David, Jack, and any others that have been thinking about and looking into the digitization of agriculture and the communications amongst farmers on digital platforms. I'm just curious, as precision agriculture becomes more widely adopted, and therefore farming operations are much more, if you will, governed by the digital aspect, to what extent are either private, providers or public extension services able to simply access the farm's data files or data fingerprints in order to assist the farmer in the management? In other words, I'm envisioning something akin to, a business having all of its accounting in QuickBooks, and therefore then their accountant can just log in or even be actively monitoring the books, even in an automated fashion, in order to make sure the business is running smoothly and there haven't been any major problems. To what extent is IT and digitization in agriculture going to be leading us into that kind of aggregation?
Okay, I'll start. Nice to hear from you, Greg, by the way. So I think that you're going to find that it just depends. And I think that by that, what I mean is that for some of the producers of the relevant technologies and software that might enable precision agriculture, they might actually be able to do that kind of consultative work directly with the farmers, and indeed sell that as a kind of a companion service. So I think that's that for a long time I think has been the idea of IBM essentially working with the farmer, much in the way that IBM through the weather company delivers real-time weather data to cockpits of aircraft, and works in conjunction with the major airline companies in order to be able to provide that kind of service, and so it ends up being fairly interactive in that respect. So I think similar sorts of things are envisioned for precision agriculture, but there are other situations where you will have on-farm machinery that is no longer user serviceable, and there's maybe a right to repair kind of issue arising there, but some of that some of the farm equipment now is no longer end user repairable, and there is data which is taken off of those machines and used by the companies that sell those machines. So John Deere, for example, will inevitably collect all of that information to actually understand the on-farm performance of their machinery, but they're not sharing that with the farmers. Some people have gone so far as to say that this poses some kind of a national security threat, in the sense that some of the machinery which is not produced in the country that's using it is actually essentially giving away information at a very localized production level to out-of-state interests, which you can sort of hypothesize might be everything from benign in the way that you sign end user license agreements all the time that end up collecting data from software that you use, all the way to the completely nefarious. So I think that it's quite a wide spectrum, and that's why I was encouraging to have some kind of public approach that is international in its scope to be able to actually contemplate some of these issues a bit more deeply.
One follow-up to David's comments is in one of our webinars this summer, we had one of the John Deere representatives on, and he was commenting that, I mean, the kind of information that they're most interested in directly is kind of information on the equipment itself, and when is it starting to have problems. Often through their computers, they can they'll know more quickly than the farmer when there's some kind of problem about to happen with the machines. And so and because the during the shutdown from COVID-19, because a lot of the mechanics, et cetera, couldn't get out to look at the machines, why farmers were pretty pleased with the kind of information and technology suggestions the companies were able to give them, so it's likely that, well, who knows? I mean, this was all from John Deere's perspective. So obviously they're optimistic about how useful this was to farmers.
Carl, I had a student last fall tell me that they were combining on the weekend, and when they got to the end of the field, the service rep from the dealership was there with a truck. They said, "We were monitoring your combine at the shop in town, and we noticed you're putting over more grain than we think the combine should be." So they were there at the end of the field to reset the seed monitoring on the combine. And like you say, that the farmer really had no idea that it was putting over more than it should be, but the equipment dealer did.
Yeah, shades of Big Brother.
Yeah.
So, I think at a more pedestrian level than the sort of high-tech John Deere type stuff, as you have greater digital communications between farmers and extension workers and salespeople and so on, I think there's really a lot of grave risks of lost privacy, of farming practices, and even the ideology of the farmer is somehow or other exposed in ways that may not be desirable for all the individuals involved. So I think we're still at a pretty early stage of developing reliable, good practice at that level.
Maybe
Great,
I'll ask,
thanks.
could I ask another
Go
question?
ahead, Carl.
Yeah, of Jock. I was wondering, in looking at the, extension services and their use of these electronic, communications and stuff like that. Are there some countries in the developing world that are kind of ahead, that are kind of examples of good practice on the use of IT and extension?
Yes, I think Kenya leaps to mind as probably one of the best sources of, let's say, cutting edge innovation and practice. And Michael Kramer, who I mentioned, was talking this morning at FAO about this, for example. They have quite a lot of carefully randomized controlled trials on the effectiveness of different types of messaging practices, for instance. So, and some of this is already published, like in Michael's science article a few months back at the end of 2019. Carl, do you want to talk about more of your precision farming digitalization stuff that you're working on?
No.
Okay.
Can I float a second question?
Sure, go ahead, Greg.
A phenomenon that I know I've heard of from folks like Corteva is the increasing use of the IT and digital platform for guiding the breeding programs, whether it's the high throughput kind of stuff that David at least touched on as one of the mega trends there. But where I'm interested in going with this question is to places like you're speaking of here, Jock, in Africa, Kenya or whatnot, and whether any of the international or national public sector plant breeders might be using in-field performance data to optimize their breeding efforts in terms of producing better. I mean, we know the stock traits that we want. Okay, we want higher resistance to such and such a virus. That doesn't really, that's not necessarily location specific, but there might be more nuanced traits that looking at the intersection of geography and genetics, or the G by E type analysis, genetic by environment analysis, can be greatly enhanced by this sort of users generated data.
Well, I would certainly agree that they should be. I don't have a lot of good case material to report on that, but Carl, we recently did a survey of what the pandemic is doing for some aspects of agricultural research, and Carl's on top of that survey. Do you want to comment on any aspect that bears on that Greg's question, Carl?
Well, I don't know. I mean, the international centers are certainly using, see, am I on? Yeah. International centers are certainly, making more use of their networks, with the national systems to, collect data and make use of data. And my memory is that they're also, doing a lot of things to try to reduce the amount of scientists that actually have to go out to the field right now when the pandemic is a problem. So there certainly is pressure right now, in particular with the pandemic, to use electronic means much more extensively. The thing that I thought of, Greg, when you were talking about it, is that some of these public-private partnerships, like this thing that used to be the Water Efficient Maize for Africa, which was a partnership of then Monsanto and Smyth and 5 national systems. I mean, that generated a huge amount of data on how different varieties operated in mainly, I think, the experiment stations of those national countries. And I've often thought that the major thing that Monsanto got out of this, this public-private partnership that went on for, I don't know, probably about 8 years, was a huge amount of data that is now in their database to be analyzed by, and I'm sure they're using it in their breeding programs. The other thing to look at, Greg, would be some of the stuff that CGIAR is doing in their big data platforms, and maybe to check with Brian King at CIAT about the extent to which they're making use of farmers, because I'm sure that there is some of that going on. I just can't remember specifics of it, but if you look at the CGIAR's big data program, I think there's some examples there of where they're using farmer data. farmer provided data.
Right, thanks.
If I could hop in for just a moment with the CGIAR projects. Actually, one of the case studies that we did with the tricot, the triadic comparison of technologies, that was done with a novel approach where 3 seed packets were delivered to farmers, and they rated them at the end of the growing cycle, and they also rated them in comparison on a number of vectors, I guess, in terms of their performance, but also in comparison with their local varieties. But they didn't know which ones were which. And at times with these projects, when it's been available, they've had remote sensors to monitor environmental data and check soil conditions, and then used that in their analysis as well. But interestingly, I mean, the farmers provide this data in the form of ranked order preferences through a survey on their phones. I think there were some paper surveys, but most of them were through this digital communications technology in the form of cell phones specifically. They had an app for it, and they'd fill out the survey, and then that was used, I think it's a Bradley-Terry statistical model, where essentially they just compile the rankings for each variety, and then they can also analyze that with respect to the locations that they were grown in, because they can double check, or they can find out where they were grown and what the weather conditions were. So that's not an example of precision agriculture necessarily, in the sense that there aren't really sensors or anything, but they are using farmer inputted data. And I think with that citizen science idea of this sort of mass distributed and low cost, effective scaling project, I think that ties in really well. But yeah, CGIAR was the organization that ran those projects. So,
Thanks, Jack. Anna, you had a question.
Thanks, Stuart. Yeah, I have a question for Intan. Well, first also an observation. I really enjoyed your presentation. Always excited to see networks in any shape or form. I work a lot with them. So I thought it was an insightful way of looking at that kind of data, to make it geospatially, to connect it to the geospatial data and then display it that way. So I look forward to seeing the methodology. You had mentioned that you're putting that together. So I have a lot of questions related to the technicalities, but I think in this particular setting, I'll ask a more general question related to that. And so you've looked at patents and scientific publications in trying to map out the innovation landscape. So I was wondering what factored into your decision to select those 2 types of outputs, and how do you think that affects how you drew the boundaries around actors or organizations that are portrayed or part of, encompassed within your study?
Great, thanks for your question, Anna. So why we use patents in scientific publications, mainly because we have access to them. So for the longest time, we've looked at patented patents, right? And we know as innovation economists that patents is really a subset of all the research output that's in the area. So scientific publications was another way for us to look at it. In fact, when the discussion started with Greg, we had this ambitious plan of also including animal related biotechnology as well. But we stopped that particularly because we realized there were some issues with regards to our search strategy and identifying what was considered innovation and invention in animal biotechnology field. Because in some cases, a lot of the things that we were capturing through the international patent codes classification were really related, could also fall into something that is meant for humans. So it's something that we're ongoing, and it takes a lot of work because we work with patent examiners. So that's one way that we are able to make sure that what we're looking at is really the field that we're looking in. Yeah, I mean, we do realize that there's so many aspects of plant biotechnology that we're not capturing. We're very well aware of it. But this was a way for us to have an insight. And one thing I didn't mention in the report, in the presentation, is that we realized that one of the ways that we could convey some of the economic thinking in this area was to use case studies. And agriculture biotechnology was one of those that we thought, hey, this could have relevance for developing countries, because every time you look at innovation, specifically discussions on innovations, you're talking about your semiconductors, robotics, AI, and so on and so forth. So agriculture was one way to tie in to actually see, okay, if we want to talk about innovation and we want to talk about the spread of innovation and its diffusion worldwide, we need to look at something that's relevant for everybody. So agriculture is one way, and plant biotechnology was one of those that we thought could do that. Of course, we're very well aware that specific countries don't allow for patenting in specific, for plants, for example, right? So that's why we thought scientific publications would also be useful. But then to plug in into the discussion that that basically David, Carl have been talking about, which is the digitization, right? What has been really interesting is the role of how big data has been in improving agriculture. And what is very interesting for us is that, so our next report, the next World Intellectual Property report, is going to focus on the direction of innovation. And one of the things that we realize is that one of the new things now is, it's not new, it's called the digital general purpose technologies. So technologies that have basically been applied in different places. So for example, with AI, that have improved and changed the field. And this is something that we're looking at. And the discussion today is basically telling me we really need to look at the digitalization and the whole discussion about the fourth industrial revolution. So that's very interesting.
Yeah.
Thank you very much. I was also wondering if you have any plans in mind of looking at flows of funds related to innovation.